it, feel stragglers coming in. So we'll give it another minute as we wait for other people to come in. Okay. Hello. Hi. Welcome to CU Data Week. Thank you so much for being here. If you have been to the other sessions, I hope you've enjoyed what you've learned about so far. So thank you so much for being here. I wanted to just sort of give a little bit of a plug. We at the end of the session, I'm going to put in an attendance link towards the end that we would ask you to fill out. Not only does this enter you into a raffle to win prizes at the end of Data Week, but it also is great to kind of to give us feedback on what you liked or didn't like about the session and what you would like to see from us in the future, whether specifically about this session or just overall, topics that you would like to have. So yes, like I said, this also enters you to win a prize. We're going to announce 5 winners at our stat soiree, which will be tomorrow afternoon from 3 to 4:30 at the Fugolini Pavilion at CU Anschutz. There will be desserts and drinks there. So we hope that you can come. There will be 2 door prizes. So when you come, you're going to get a little raffle ticket. And we're going to announce the winners of the door prizes as well as the winners for the attendance raffle at 3:45. Now, you don't have to attend to win one of the 5 prizes for participating in CU Data Week. We will be sending out emails to the winners on Friday morning to let you guys know that you guys won and to kind of pick the prize that you want. But to win the door prize, you do have to be at the soiree and be there at 3:45 when we announce the winners. So please come and attend. We would love to have you there. I'm going to put in a link. We have one more session with so I'm going to put the registration link here. We have one more session tomorrow at the lunch hour from 12 to 1:15. It's basic statistics in SAS, which is a great companion to this basic data management in SAS. So I highly recommend that you go and participate in that lesson. I'm also going to put in the information about our soiree tomorrow so you can have that information easily accessible and hopefully you can come and join us. That would be super great. Okay, and so today we have Betty. She's going to be talking about basic data management in SAS. We are so grateful that she is here to, inform us about data management in SAS. So thank you so much. Betty, take it over.
Okay, thank you so much, Samantha. Good evening, everyone. As Samantha mentioned, today I'll be going over basic data management using SAS. Let me go ahead and share these slides. Are you able to see my presentation, Samantha? Okay, awesome. Thank you. Yeah, as I mentioned, today I'll be going over basic data management using SAS. And some agenda items that we'll be covering today is what is SAS, how to access SAS products, some data types and operations in SAS, how to set up directory, how to import data. We'll also go over SAS programming basics, and then we'll do activities for variable creation and transformation, and then finally how to export data. And as I go through these topics, I will stop eventually to see if you guys have any questions or not. So if you wouldn't mind waiting until then, and then you can unmute yourselves or put them in a chat as we go through and reference back. Okay, so what is SAS? SAS basically stands for Statistical Analysis System, and it allows users to work with data specifically to either access the data, manage and manipulate the data. You can analyze the data and also create reports. And then the base SAS is basically the foundation for all SAS softwares, and it provides a very flexible programming language, a choice of programming interface. It has a huge selection of programming procedures, including procs, which stand for procedures, to accomplish different goals. Now, to access SAS products, there are a few different ways you're able to access it. The first one is using the SAS on demand for academics, which also is known as SAS Studios. This is also the browser-based SAS programming that we'll be using today. It's very useful because it's a free cloud-based environment, which is a great way for new programmers to start on, especially because you can access it and log in with your information from any browser. However, it does have its downsides, which is storage. So SAS Studios only has about 5 gigabytes for storage space. If you would like to set up and follow along, the links below, you'll be able to initiate your SAS Studio as well. So the first link is just to set up your information, and then the second one is just to launch the SAS Studio. The other one is a SAS license version, which is a windowing environment that is accessed by paid users license. So usually with the work that I'm doing, my colleagues and I, we use the SAS licensing version. And then the last one is the SAS Enterprise Guide. Typically is a point and click user interface, but then again, this is also a paid user's license. Before we move on to SAS, I want to just quickly talk about the types of data. So in SAS, usually we have 2 types of data. The first one is character. This is when the data is considered a string, or it includes any combination of alpha, numeric, and special character. So typically these are things like name, medication or medication type, smoking status, diagnosis type, and so on. And then the other one is numeric, which is where the values only include numbers, decimals, or negative values as well. So usually values that are without a string. So this can be things like age, date of birth, some lab values if they don't have units in them, and so on. And I'll also show you how we can be able to tell the types of that using SAS Studios in a little bit. And then some terminologies that you'll be hearing me mention is for data tables, we usually call them data sets. So this includes any type of file you're working with. It could be Excel, TXT, or CSV. And then the rows in that file are usually considered observations, and then the columns are variables. And then I've also included some operations in SAS. We're going to be practicing with some of them here, but this is just symbols and what the operations include if you're doing calculations or implementing it in your data. And then at the bottom, you can see there's a link there. You can directly access to the SAS documentation. SAS documentation is basically, it includes any type of information or operation or function. We typically use it to get information on different types of operations. So there's a list of those, including what they're able to do. So feel free to check that out as well. So now I'm going to transition to how we can set up our SAS Studio. Okay. So once you click on the link that I've showed you earlier, you will see a screen that says launch. So basically all you have to do is click that launch button so you'll be able to access your programming interface for coding. And then once you log in, just a few things to talk about. In the top left corner, you see server files and folders. This is basically an area where you'll be able to set up your cloud-based folder structure. And then in the middle, you see code. This is basically a section where you can code and interact with SAS for coding. You could submit a statement using the running man here, and then make changes as you please. The next one is the log. this is basically when we submit our code, we can get messages from SAS. It can either be a summary of what was able to process. You can also get errors, warnings, and notes, depending on how the SAS was processed. So it's important to make it a habit to check the logs as you go with your code. And then the next one is results, which is after you submit your code and generate some sort of results. It could be graphs, tables, or any type of output it will show here. And then at the bottom, you see there are tasks and tools which you can utilize if you please. We will talk in depth about libraries, so I'll come back to that. But I'm going to move on to setting up folder first. Before I do that, from line 1 to 13, this is basically the title page. We make it a habit when we're working with SAS to just have a project title, what is, the name of the author, the date it was created, and the last time you revised it. And you can write a purpose for the programming. Also at the bottom, you can write notes for what changes you've made, or if you have some comments for another analyst or your investigator to review the code as well. So here on our list, the first thing we want to do is create a parent folder. So the way to create a folder is if I come here to the server files and folder and go to my file, I will right click here and then click on new. You can list, you can open a new SAS file if you want. You can import a data and then create a folder. So for this case, I'm just going to create a folder that's called practice. And then if I come into the home file, I see a practice folder. And then within that folder, I also want to create another subfolder called data raw. And this is basically where I will be importing my raw data into my SAS studios. But then I also want to create another folder that is for the clean file. Typically, we don't mess with our raw files directly to avoid any type of manipulation. So I'm creating another clean data where all my clean files will be saved here directly. So now I have my practice parent folder, and then I have my data clean and data raw subfolders. So then we're going to move on to importing my file into the raw data. So the way I do that is I come to the data raw folder, and then I again right click, move on to upload files. And then I'm just going to make sure that I am looking at the correct location. So this is what we call a pathway or location. And it's important to make sure that I'm creating it within the practice folder in the data raw. So I'm just going to go ahead and choose my files. You should have access to all these documents. If you haven't, please mention it in the chat. And then myself or Samantha will direct you to the OneDrive folder. There are different types of versions here. You can see the CSV file, the Excel file, or TXT. I'm just going to go ahead and select the CSV file since that's the one we're going to be working on today. And then once I select it, it is telling me it's ready to import the CSV file titled birthweight_CU dataweek.csv. And I'm just going to say yes. So once that is created, I see the CSV file within the data raw folder. I'm going to quickly stop for a second and see if there are any questions. Okay. Okay, so now that we have uploaded our CSV file into SAS and we're going to start manipulating the data is no longer going to be a CSV or Excel file. We would like it to be a SAS extension type file, which is a SAS dataset. So in order to interact with these datasets, we need to have them stored in SAS libraries. So what does that mean? What do I mean by SAS libraries? You mentioned earlier at the bottom left corner, you see the libraries. And within that file, you see all these folders that are automatically included in SAS. So anytime you log in, you see them directly. Now, the work library at the bottom is a temporary library. So anytime you work in SAS, once you can work in SAS and the files will be stored in the work library if you don't have a permanent library. But because it's a temporary folder, when we log out, let's say you end your session, your work is going to be gone by the time you log in. So it's important to create a permanent library within the library parent folder. So one thing to talk about with the work library, why do we do that? Maybe you have a large data set that you're working with and you're not sure if your code is automatically going to be working. So typically you can set it to the temporary work library and run the code to avoid a large amount of space usage because again, the SAS Studio only has 5 gigabytes. However, because we want our data to be permanently saved, we're going to move on to creating a permanent library. So to create a permanent library, the first thing that you need is a library name, which is called libname in SAS. And then the libname consists of a 2-step level name. The first one is called a libreference. And a libreference is a user-defined statement. So you are in charge of telling SAS where you would like the library to be stored. So you can name it any name you want. Typically, SAS is very picky, so it has to be less than 8 characters long. And then you follow it up after the period with the dataset name. So some example could be, SAS help. This is the library reference, and then the class is the name. So if I come to my library, I should be able to see a SAS help, which is right here. So this is essentially the parent folder in the library. And then within that, I should be able to see a class data set. So we would like to create one for our own data set. And then for the next example, which is work, because this is a temporary folder, the trial data set that I already created is not located in there anymore because this is a new session. So we're going to go to how do we set up our own directory and how can we assign a library name. So the first thing we can do is we can use a %let to create your pathway or to the parent folder. So if I come back to the server files and folder, I can go ahead and select the location of the file here. So basically, if I go right-click and then go down to properties, I'm going to see the folder name and then the location. So I can go ahead and select that and make sure that it is the one that I want. And this is important just to make sure that we are not rewriting this again and again. It's just a simple way to already assign the parent pathway, and then you follow it up with the libname. So I'm going to go ahead and run it. And then in the log, I should not be seeing no errors or warnings, and it's telling me that the %root pathway has been assigned to the CU data week folder. And the reason I did that is I can also assign it to the practice folder if I want to, but today we'll be working on the CU data week folder. I already have it imported. And then we end every line of SAS with a semicolon. So before you run it, make sure you're ending it with a semicolon. So now that I have my path root already set up, I'm going to proceed to writing my libname or assigning a library name. So we started off by saying libname, the library reference name that I want, and I want it to be under my data raw folder. So I'm selecting the pathway to the data raw folder. And then I'm also doing it for my data clean. And then I'm going to go ahead and run it. And then SAS is going to tell me there are 2 libraries created using the library reference called data raw and then data clean, and they were successfully created. if I come down here to my libraries, I should be able to see my data raw and data clean. So essentially, this is what it means by making sure SAS is interacting with the libraries. So now that we have our library reference set up, and we can go ahead and proceed to reading in our data file. So right now, the CSV file is located under the file folder and it's not in the library, so we need to import it into the library. So in order to import data, we are using a proc import. There are 3 different versions that I've listed here, and they're for specific files. There's a CSV one, there's an Excel one, and then also a TXT version as well. So to import data, we start off with a statement called proc import. The data file is basically the location of where your raw data is located. So in our case, since I'm working with the CU Data Week, if I come down here to data raw, I just have to click on the CSV file, right click, and then select the properties and find the location here. And then the out is basically telling SAS to create a data set with your name of choice, making sure that it's going to my data raw library. And then I'm calling it birth weight _ C. If you don't specify a library reference here, SAS is automatically by default going to save it to the work library. So that is why we are making sure to tell SAS, please save it to the data raw. And then DBMS is basically the type of file. You can specify CSV, you can specify Excel if it is an Excel. For TXT, it's a little different, so I'll come down to that in a second. And then the replace is basically telling SAS, if I have this file for some reason in the past, make sure to replace it with this one. And then the get name is basically telling SAS that I want you to look at the first row in the raw data or the raw CSV file and include the names or the first line as variable names and not observations. So this is just telling SAS to make sure you do the first line as variable names. And then the guessing row is basically telling SAS that I want you to look at the first 150 observations in order to determine my variable type. So SAS is going to run through 150 of the first observations and tell you the type of data. So it can tell you if it's importing it as numeric or character. Typically, if you're working with a smaller data, you don't need to specify guessing row. You can put it to the maximum number of observations you have. But if you're not sure, sometimes you can work with thousands or millions of data to save running time. It's important to specify guessing rows. And then I finish it off with a run statement. So typically in SAS, we close off the statement by run and then a semicolon. So let me go ahead and run the data. So I'm going to go ahead and check my logs. I'm not seeing no errors or warnings. And it's telling me data raw, under data raw library, birth weight _ C was successfully created. And then it's telling me that it has 50,000 observations and 12 variables in it. So if I come down here and look at my data raw, I should be able to see my birth weight _ C. So now we can work with this data essentially. The proc import is basically the same thing. It's just specifying the DBMS as Excel. I've listed some extra options. You can specify the sheet name. Typically with Excel, you can have multiple sheets, so you can specify by that. And then the data row, you can also assign SAS to import which row you would like it to do. The TXT is also similar, except you have to specify custom delimiters by using DLM. So for DBMS, instead of writing TXT to specify text files, you write DLM to say, I'm going to tell you to specify it by a delimiter. In this case, if you look at the raw file, the delimiter is a comma. So in quotation, you can put that in there and you can have the file imported as well. So I'm going to stop quickly and see if there are any questions so far. Will this recording be available to us later? I believe so, yes. Yes, we will be saving it at the end of this session.
The recordings will be available online next week on the website, on the CETA website.
Okay. So I'm gonna move on to talking about some programming basics. As I mentioned earlier, it's important to refer to the documentations. You can use SAS support to ask any questions you might have. You can also look at the SAS documentation to list out any questions you might be interested in. So in SAS, there are two types of data sequences that you can do. One of them is by using a data step. Typically, we use this to create or manipulate a data set. And essentially, it just starts with a data statement. And then you're essentially saying, create this new data set. And then the set is basically saying from the old data set that you are interested in creating. So in this statement, I'm saying create the data set 1 from my data raw dot birthweight underscore C. And then the proc steps or procedure steps are typically used for SAS data sets and produce reports. So you can do proc contents, which basically gives you a summary of what's in your data. So if I go ahead and create this data, and then I'm telling SAS, I want you to give me some information, and I run it, SAS is automatically going to generate this report for me for proc contents. You can see that the dataset name is work.dataset1, which is the file that we just created. There are 50,000 observations, 12 variables, and then also at the bottom, it gives you a list of all the variables. And then one more thing to list off in the output. Right now we have all these variable names included, and SAS Studios, it gives you a total row and summary up here at the top. And then only previews 1 to 100 rows. So if you're interested in looking at other rows, you can click these buttons to move it. And then one thing to also note, to identify if a variable is numeric or character, you can quickly reference here. If it starts with a circle that includes 1, 2, 3, it's numeric. And then if it has a triangle with an A, then it's character. Another way to identify that is also by clicking on the variable. When you click on the variable at the bottom, it tells you the type of variable here. So it can either say numeric or character. And then a few step boundaries. Each data set will always begin with a data statement, as I mentioned earlier, or a proc statement. With a proc statement, you follow it up with the type of proc you are interested in. So you can specify that. You can use a proc frequency to look at the frequency of a variable. And this will be mainly discussed in tomorrow's session for the basic statistics as well. And then you end SAS statement by using a run or a quit statement. We usually like to practice that, or SAS will automatically will end that statement by the beginning of another step. But to prevent that, we usually use a run or a quit statement. And then there are some overviews for the coding colors. SAS is not case specific when it comes to capitalization, unless it's in quotation mark. It could be a single or double quotation, it doesn't really matter. And then indentation or spacing are also best practices, just to make sure that your code is clean and it looks nice for other coders to see as well. So I'm gonna move on to our slide real quick, just so we can talk about our exercise. So you have met with an investigator And they're looking at the relationship between multiple factors of mothers and babies from a maternal and neonatal health study. In order to answer their research question and hypothesis, we need to clean and manipulate the raw data source. And you also have received a data dictionary and a data file. So the file that we're going to be working on, we already imported. If you want to access it, you can go ahead and click this button here. You will be directly linked to the OneDrive, so you're able to go as we are working on it. And these are the variable lists that we were able to import in our data. Some key points to remember is we do not make changes to the raw data set in whatever form you receive it. And then we also do not overwrite variables original to the raw data set. So every time we make changes to the raw data set, we have to create another data set and make changes on there and not directly to the raw data. So now I'm going to go back to my SAS Studios. And upon meeting with the investigator wants you to convert the mom education level variable into a character variable. They also want you to calculate BMI from height and weight, creating BMI category using the BMI variable that you're going to create from step 2, assign birth weight as binary variable, so 1 or 0, using the 2,500 gram cutoff point. And then they also want you to create a dummy variable for self-identified race. And finally, label variable names. So let's go over them one by one. Converting numeric to variable or character to numeric, there are 2 ways to do it. One of them is converting character to numeric variables. Why is this important? Maybe we need to conduct some calculations and they must be numeric. One example is the BMI calculation that we were just looking at, where the height and weight have to be numeric, and maybe you received it as character, so you need to convert it into numeric. This could also happen with lab values. Sometimes you can receive it as character, but you need them to be numeric to do calculations. So in order to convert a variable from character to numeric, one thing you can do is using the input function. So the way we use the input function is by creating a new variable. So in this case, I'm saying new var equals input from the old variable in parentheses, and then you specify the length. Typically, the length for numeric variable is going to be 8 in SAS. You can specify it as much as you wanted, but this is going to be 8 regardless. And then another way is numeric to character. So you might need this number not necessarily for calculation. You just need it to be in character format. Sometimes investigators might tell you for zip code or MRN, they would prefer to have a character variable. So you can go ahead and convert that. It's still the same procedure, except instead of the input function, we use a put function. So again, you can say a new variable, create a new variable using the put function from the old variable, and then specify the length. And then for our own question, our goal is to convert the mom education level into a character. So we'll be using a put function. So the way to do that, again, we're not going to be manipulating the raw data. So I need to create a new data set. So in this case, I'm telling SAS using a data step, create birth weight from the raw data that we just created. And I want you to create a variable called mom education by converting it, the mom education level, and then giving it the length of 1. And the reason I gave that is if I come here and I just look at the mom education level, I can see that the maximum number I have is 1 character long. So that's why I'm specifying it as 1. And then I close off and I close it with a semicolon, end it with a run. And then I'm going to go ahead and run it. So before I look at the output table, I always look at the log just to make sure it's working properly. I can see a new data set was created, and it has 50,000 observations, but 13 variables. So this is how I know is, the new variable that I just created has been implemented correctly. And if I come down here, I see mom education, that is a character variable. And then the next step on our list is creating new variables by calculating height and weight to create BMI. We're also interested in categorizing BMI. So I'm going to start off with calculating BMI first. So if we look at our BMI data, just going to specify the weight and height for a second. Here you can see that the mom height is missing, but the mom weight is not missing. And then if I go to the next line, the mom height is not missing and the mom weight is missing. And then there are instances where both of them are not missing. So when I'm coding, I need to tell SAS to account for the missing values as well. So essentially, if the mom height or the mom weight is missing, I don't want SAS to calculate BMI. So I need to specify it in SAS. And the way to do that is using the if-then statement. The if-then statement is very popular in SAS. It's one of my favorites. You can essentially think of how you want to code your statement and then implement it with if-then statement. So I'm going to start off and tell SAS if the mom height is missing or the mom weight is missing, then I want you to create a BMI variable and assign it as missing. And then one thing to note, if a variable value is numeric, it's going to be a dot when it's missing. And if it is a character, it's going to be an empty value with a quotation. So if it is a character, it would just be a single quotation or a double quotation. But since it's numeric, we're just using a dot. So now that I specified for the missing values, I'm telling SAS if it's not missing using else, create a BMI variable by calculating the mom weight divided by the mom height to the power of 2 times 703. And this is where we use the operations from the list that I showed you earlier. And also the calculation is just one used for BMI according to the WHO. So now that I specified that, I'm going to just close that statement just to see if it's going to run it correctly. So I'm going to go ahead and check my logs. Again, there's 14 variables created, which is exactly what I wanted. 50,000 observations. I'm not seeing no errors or warnings. And then if I come down here, I can see BMI. So let's check the mom, the height, and the BMI to see if it is executed as I wanted. For the missing height and weight, BMI is also missing. For the missing weight and non-missing height, BMI is also missing. However, if both are in there, then the BMI is calculated. Another good thing about SAS is you can execute multiple statements within the same new file that you're creating. So I'm going to go ahead and also create a BMI category. In order to create a BMI category, the first thing that I need to do is specify the length. It's important whenever you're working with a character variable to specify the length to avoid truncation. And the way I'm doing that is I want you to assign a length for a new variable that I'm going to create called BMI cat, and the maximum length will be 14. And then the money sign is basically used to specify character variables. So whenever you're working with a character variable, you use a money sign. And the reason I chose 14 is just because that's the maximum number of variable length that I'm using, keeping in mind that this data, I already wrote the code, but if you're unsure, it's better to make the length as maximum as possible just to avoid any type of truncation. So now that I have the length for the BMI category set up, I'm going to go ahead and proceed to creating BMI category. So again, accounting for the missing BMIs. So if BMI is missing, then the BMI cat will also output missing. And I'm putting it in quotation mark because I'm dealing with a character variable. Else, if BMI is less than 18.5, then the BMI category will be underweight, and so on and so forth. When working with a category, creating a category step, SAS basically processes the if-then statement line by line. So the way SAS works is it will assign for the missing as missing category, and then it will go to the next step and assign the next, and goes to the next, and so on and so forth. So it's important to kind of think about how you want to program it when you're writing the code. And then finally, I'm also labeling variables just to save time. The way I'm going to label it is for using a label statement. Maybe I want, the mom weight and the mom height to actually have a label called mom weight and mom height, because I don't like how it's written here as a variable. So I can specify it that way. And the label statement, because you're going to be labeling it in character format, you will be putting it in quotation marks. So now I'm going to go ahead and run it and see what happens. So I'm going back to my log again, and I'm not seeing no errors. Now I have 15 variables because I created the BMI category, and I should be seeing it here. I'm seeing that it is a character. If I click on it, it will tell me that I have assigned a 14 length. And then if I look at the BMI and category for the missing ones, it is missing. And then for those that are not missing, it's assigning it correctly as I want it. So now I'm going to move on to the next step, which is the investigator wanting us to create a dummy variable or indicator variable. So there are two types of ways you are able to create those. One of them is assigning a binary variable, which the investigator wants us to assign a birth weight using the less than 2,500 grams for underweight. And the investigator would like us to assign it as a value of 1. So again, I'm just using the same procedure. If the weight is missing, then you would just assign the low birth weight variable that you're creating as 1. Keeping in mind, we didn't put it in quotation because we're creating a numeric variable, and we're not assigning a length statement as well because we don't need to when working with a numeric variable. And then I'm telling SAS, else if the weight is less than 2,500, then the low birth weight will be 1. And then if it's not missing, or if it's not less than 2,500, then I want you to assign it as 0. So I'm going to go ahead and run that statement quickly. And I should be able to see the low birth weight variable here. And if I also move to the end, I'm able to see the low birth weight, and it's assigning 1 or 0 based on weight. And then the final thing the investigator wants us to do is create a dummy variable for self-identified race. So a dummy variable is a binary indicator variable. So given a categorical variable like X, and it has, a number of levels, for example, race has about 5 levels right now, you could essentially create a new dummy variable for each indicator using the race variable. So by creating that, you'll get a result if it's present as 1 or if it's absent as 0. So here I'm telling SAS, I want you to create another variable called Asian indicator from the race variable where race is Asian. And then I'm also doing it for other race categories as well. Keeping in mind, in quotation mark, if the Asian variable listed in race was capitalized, we would need to make sure that we also implement it here. If you don't implement it capitalized, then SAS is not going to know which variable you're referring to, so you'll get an error. And then finally, I'll just, label the low birth weight variable. Maybe I forgot to label it here, so I'm going to label it as low birth weight because I like how it's presented by using this. So let's go ahead and run this and look at the logs. So now instead of having 16 variables, I have 21 variables. This is because in the SAS, I specifically asked it to create a dummy variable for each race indicator. And if I look at my output, I should see all the race indicators as 0 and 1 listed here. So if I move to the end, let me actually specify it just for race and the indicators to make it easy to see. You can see for patient ID 1, they're listed as Asian, so I expected to have a 1 for Asian indicator and a 0 for the rest. So that's how you know it has been executed correctly. And then another thing we can do is we can use a proc print statement just to look at the output of the data. Maybe I just want to see what the data looks like overall instead of moving it left or right to see the full picture. So I can use a proc print statement. So a proc print statement starts with, again, with the proc. I'm specifying it as print, and I'm telling SAS to print from the birth weight 3 variable or data set that I just created. And then because I have about 50,000 observations, I don't want SAS to print the entire 50,000 observations. So I'm going to use an obs equals option to specify how many I want you to print out. So I can specify this as the first 10 variables I want you to show me and show me the output. If you don't have a large amount of data, then you are fine to not include the obs equals options. But if you're working with a large data, it's important to include that. I'm closing it off with a run statement, and then I'm going to go ahead and run it. So now I can see clearly that I have my ID, my weight variables. Using the weight variable, I'm able to assign low birth weight. I have the new variables that I've created, and they're correct because it's assigning it correctly. So it'll give me a better understanding of my data. You can also add a title to it just to keep records of what you're printing. So this can be using the title statement, and you can list what you are specifying here. And then I'm going to go ahead and run it. So essentially you have the title and then the output of your data. Now a title statement will remain on for the rest of your statement unless you close it off or clear it. And that is by using the title semicolon. So it's important to close it off. So you can go ahead and run it. So that way it's not using the title for any statement that I'm using afterwards. And then just for extra cleaning, maybe we don't need some variables and we would like to drop some variables. So the way to do that is by using a drop statement, and there's 2 ways you can do it. The first one is you can create a new data set. I'm creating it from the birth weight 3 data set that we're working on. And within the set statement, I can include a drop statement and write the variable I want to drop. And you can list as many variables as you want. I can even say, I want you to drop mom age and run the statement, and it will drop it as well. Another way is also by including its own line of statement and specifying the variable as well. So if I go ahead and run this, I expect to get 19 variables because I'm dropping 2, and SAS will tell you that there are 19 variables for this data set. And then finally, now that we have everything cleaned up, I want to export the data and save it as CSV for the investigators to see. And the way I do that is the same procedure as proc import, but in this case, we use proc export. So I essentially start the statement with proc export, and I'm telling SAS I want you to export this data that I just created, which is birth weight 4, and then I want you to place it into my data clean in the parent folder, my data clean, and I want you to call it birth weight underscore clean.csv. And the data type is also going to be CSV. And if I have this file in the past before, please replace it, and then you just run it. So essentially, SAS is going to tell you that the file was successfully created. And then if I come here to my data clean folder, oops, sorry, in the library, here, I should be able to see my birth weight underscore clean.csv. So I'm going to go ahead and stop and see if there are any questions so far. Okay. I have some extra materials here at the bottom. If you would like to refer to, included are things like merging data. There are 2 types of ways you can merge data. I also have how to sort a data, how to rename data sets, and many more at the bottom. So thanks so much for attending the session. And again, just a few announcements. I think, is there another question? Yeah, okay. Just a few announcements. Samantha just put a link for attendance entry. If you can fill it out with the link, you can enter into the raffle for some exciting prizes. And then Samantha, if you want to add anything more.
Nope. Just make sure to see if there's any questions. The attendance link is in the chat. If not, Betty and I will stay on until, just in case there are some people who want to ask questions when there are less people here.
Yeah.
Thank you for coming.
Thank you. Yeah.
Do either of you 3 have any questions? Okay, I am going to end it.